Okay, this is topic 2 of today's roundtable. This morning we've heard some of the benefits of BEVs, generally speaking, some of the challenges that we face and things that we need to answer. We learned really that things are being done in the mining industry that perhaps are not quite matured in the tunneling industry. So this section, we've got three guests online and 2 panelists here with me today, Marco and Remo, really is about real-world examples, right? So to give some examples of real cases where we've been using this. So two of the guests we've got online are from Codelco in Chile and from India, from Hindustan Zinc. So a very nice mining perspective, and they'll give inputs on that. But also we've got Kim Massey from Rental Group in Norway, and we know that Norway in the civil world is really pushing hard with BEVs, and I think it would be great to hear that angle as well as Marco and Remo's inputs on this. But I'll just start with a couple of slides. We have all got a challenge, and of course it is all about looking after our planet, and I think a lot of the talk is about money. And what I would like to say is that I think carbon reduction and money are linked, right? So when we start as an industry focusing on carbon reduction, right, whether it be with BEVs or with low carbon concretes or whatever we use in construction and less steel, this will inevitably lead to a lower cost project, right? So I think we're not fully calculating that yet. I mean, we're talking about less fuel this morning, but there are more cost benefits. And we know that diesel is one of the big bad boys, right, of this sustainability problem. And I think, what we're discussing today is really reducing the use of diesel and emissions from diesel. So yeah, it is about carbon, but it is also about money, right? And they are linked. And we've seen, Mark showed this morning a number of examples, and we are seeing, 40 to 60% less energy used and massive reductions in emissions if we use renewable energy to power up these batteries and these vehicles. So there must be numbers and pound signs, euro signs attributed to that, right? And hopefully today we'll hear some of those. I also think it's not all about the machines acting at the face in our tunnelling works and mining works. More of the benefits come from those vehicles moving things in and out. We heard about this load and haul and going down full and coming out empty. And I think a lot of the savings with battery electric vehicles will come from the vehicles that do long distances, right, and hauling materials rather than drilling or spraying at the face. So I think we'll hear some examples of that through today. And it's not just about energy and emissions. I think we've also heard about safety benefits. So what price do you put on enhancing safety, right? What is the value that brings? And I think all these things we need to build into kind of a whole project costing or total cost of ownership. We heard about digitalisation. There will be an increasing role of that, and we'll be able to calculate these when we get more data, in the future. Okay, so I think really we'll start today this session with a little view at the mining. We will hear what Mr. Ramirez says from Codelco, and we'll hear what's happening a little bit from Hindustan Zinc, maybe from comments added during the discussions today, and from Kim Massey from the civil side in Norway. But as we said in the last session, there are all these benefits, but there is this hurdle of the cost, this capex and opex costs right at the beginning, and how do we tackle that? And I think it's through this total cost of ownership, which works well in mining, and we'll see how well it could work in tunneling. So let's start with our panelists. I'd like to ask Gonzalo, if you perhaps could give us some insights to the benefits really that you're seeing with Codelco in Chile.
So I prepared some slides. So should I Okay, they're there. Okay, thank you. So first of all, thank you very much for inviting us. For us, it's a bit too early, but it's fine. I guess it's this is one of the topics we really enjoy to talk with all the perspective from the industry, in this case from tunnels construction. So I will go very fast. So maybe I will keep saying next if you please change the slide. I will go very fast through an introduction of Codelco just to give you, because I think in this case it's maybe if you go next, it's very important to understand what we are and how we see this problem from our side. So we are a mining operator. We operate only in Chile. We are the main copper producer of the world. And we have several operations, only copper for now. We're just going into the lithium business, which tells you something, right? But from all these operations, what are relevant on this conversation is El Teniente mine. If you hear about it, this is the largest underground mine in the world. It has 4,500 kilometers of tunnel. That is the whole Chile from north to south. It's 120 years old. And we are building a similar mine, underground mine, which is Chuquicamata Underground Project, which was previously an open pit, which is now going into underground mode for the next 50 years, and it will move more or less the same amount of material as Teniente today, which is 140,000 tons per day. So it's massive operation. So that's our problem, right? So that tells you a little bit of where are we standing, and before we are saying we are going into electric operated vehicles. So next, please. So this is our context. I will go very fast. So lower grades, complex minerals, deeper deposits. The three of those means energy, right? More energy, in summary. We have, of course, a climate change or climate crisis scenario, higher sustainability standard, and social scrutiny is going up and up every year. And we are actually operating in many of our aspects of sustainability beyond regulations. So next, please. And this is our goals. So we committed to be net zero by 2050, as many companies and governments, but with a middle step in 2030, where we committed to go fully electric. To change all our contracts to fully renewable, which is something we are undergoing now. We are already secure 80% of that goal. We are going into the direction of full electrification of our underground mine. Of course, it doesn't depend everything on us. It depends also on the market and how we can accelerate that. We will also reduce the emission of our open pits, which is our main emissions source. And also, we are a state-owned company. So we have also an interest into developing a green hydrogen market in Chile if there is a application that makes sense for the mining industry. So that's more or less like where we are going into our strategy. Relevant to say, the emissions for the underground mine is not that big if you compare it to the open pit. So, and that's the case for any mining company. If you talk about greenhouse emissions, open pits dominate the conversation. So, but there is a big addition to that I will explain the next slide, please. So basically, this whole sustainability scenario, right, commitments, it's bringing the mining industry to a different paradigm of technology, which is definitely, in our opinion, is definitely the largest transformation we will see in mining over the, 50 to 70 years. So it's definitely, we are standing at a point where the industry will change radically. So that necessarily brings a new technology vision for the future of the mine. So, please next. So, okay, I told you already that GHG emissions are not that relevant for the mining industry, especially when you're a mining operator that owns a pit, right? Which is our case, an open pit. I mean. So, but the real reason why we are doing it and why the industry is doing it is because of the reduction of diesel particulate matter, right? So we want to eliminate that. That's a legacy problem from the internal combustion engines that we have in our operation, specifically because in the underground mine we operate in confined areas. So we have a higher concentration of this particulate matter in some areas. So we're aiming to electrify our fleet mainly because of that. Also, of course, it will reduce our emissions, GHG emissions. Another benefit is we know also talked that it won't go in deep in that is, of course, the reduction of acoustic noise and vibration, heat emissions as well, very relevant when we are going deeper and deeper in our mines. So we are constructing levels below the levels we already are operating. So you experience already temperatures that are very high, and we will require more ventilation. Therefore, it's a very welcome to have electric vehicles, because if we go to the business value of this technology, you can reduce energy cost, lower maintenance, and of course the capex and opex in ventilation. And it's capex and opex because we build fixed ventilation infrastructure. So we keep operating the same mine for 50 years. So if we are able to build lower radius injection tunnels for the ventilation, that's a lot of money. So it really impacts not only the OPEX as we saw before, but also the CAPEX as well. So it's very interesting business case that as was already thought, it's a TCO approach. Of course, it has a higher investment today to buy this equipment, but in some cases you are already now able to more or less balance that equation. So next, please. So this is just to give you an idea of how it looks, a mine. This is a block cave mine, so different sectors of the mine. We're building the one in yellow, so the one below. So we're going downwards in different levels. And basically, what I wanted to say with this is it is that we have mines that are, or areas of the mine that are going out of business, mines that are currently in operation, and mines or areas that are currently under construction. And also there are mine areas that are currently under design, which is not even it's not even present in this drawing. So that is extremely relevant for us when we are talking about building a business case. So maybe if we go to the next slide. So first of all, when you plan to design a business case, you need to know where you're standing. And starting from that, you have to recognize what the problem you want to solve, or what's the case you want to calculate. So as mentioned before, we in our operation at least, we identified at least 4 different problems, and all of them have the same inputs, so same energy inputs and everything, but definitely different outputs and different goals. For instance, projects which are in a pre or feasibility phase, so on paper, we can design it as maximum value capture. We have project in engineering and construction phase. Then we are trying to keep flexible design, so at some point we will switch to electric. We have current operations that our goal is basically minimize interference with the operation itself, right? And construction and operation support. So we do a lot of construction. We actually construct more than we operate. That's because we're always like creating new areas for operation. So that's at some point we will start switching all this operation. And we, of course, what we want is to minimize the impacts on the critical KPIs in mine development. So tunnel development at the end, mostly. So 4 different problems, 4 different approach, and 4 different outputs. So that's how we start any time when we decide to build a business model. Considering all the aspects that was already mentioned, so lower OPEX in energy, lower maintenance, lower ventilation, OPEX and CAPEX, lower when applied. It doesn't apply to us. We don't have currently a tax or carbon tax or emission tax in Chile, but it's being discussed by our legislators, so we will have it at some point that will add some value. There are costs that cost reduction that we are already discovering. So if you go to the next slide, so we've been doing pilots for already 5 years for different equipment. And for instance, the last pilot we did was a LHD, so a scoop, a load hold machine. And we discovered that the noise vibration was very, very low compared to what we have today in the diesel, and that implies different mitigation measures for the drivers. So we basically moved from a high-risk situation to a very low-risk situation, and that means that we don't have to pay for all those mitigation measures like medical exams and everything. So it's not too much money, but it's still we are discovering even though we know that all these sustainability values there, we are still discovering some business aspects of it. So we decided to go for a piloting strategy from easy to the most difficult one. So we decided to be easy to abate first. And this is where we are now. So we are now at the core of our business, testing mining equipment. So we test some normal equipment last year. We are going with some others normal equipment this year and next year. We are piloting LHDs by Epiroc, Sandvik, that sort of machinery. Also, we will hopefully very soon start at the end of this year a pilot where we will have a battery electric LHD fully automated. We operate most of our mining areas in automation mode because of the geological risk you have. So it will be probably one of the first fully autonomous and electrical equipment integrated into a fully autonomous fleet, which will be definitely a breakthrough in the industry. So we also develop different agreement with the ecosystem, so we are not alone, and we have to recognize that we don't know everything. Actually, we don't nothing when we start this journey. So that is more or less where we are now. So maybe next. So one of the element of this transition is to understand that this is a transformational challenge. So as I mentioned before, we started with the light vehicles. So today we have around 300 battery electrical buses going around our mines, which I think could be, I'm not sure, could be one of the largest battery electric fleet associated to a mining operation in the world. And as I mentioned before, it's a transformation. So we started with the buses. Currently, there is no worker going into the El Teniente mine in a diesel equipment. So these small buses you see on the top are all of them electric, which is it's a very relevant point because you are dealing with a transformation where your business has to be in place, technology has to be in place, and people has to be in place. And when you expose all your workforce to the electromobility every day, then the adaptation becomes much easier. So those are aspects that we've discovered while executing this strategy, easy to abate first, right? So very interesting. So we have different challenges for different equipment. It's definitely a granular project, a granular challenge. the TCO calculations has to be for every piece of equipment, for every contract, for every operation. You will find particularities everywhere. So I won't go through these challenges, but for instance, aspects that are relevant for us is questions that you have to understand. Do you own the vehicles? Do you rent the vehicles? Do you pay for linear meter? How you are actually monetizing, how you will actually monetize the electrification of different fleets? It will really depend on the contracts and mostly aspects of how you structure those construction contract. In this case of the conversation, or in our case when we operate some of our machinery. So plenty of challenges, plenty of opportunities, and I want to leave you with one of our opportunities we were able to grasp. So as you may know, we are a mining country, but we are not a very complex industrial country as Switzerland or Germany or the countries in Europe. And we developed, because of this transition, we found that this model of buses I show you in the small picture weren't available in the market, and we end up today having a assembly plant of those buses in Chile nearby our operation, which means a lot for us, considering that we are not only there for extracting copper, but also to create value to the communities surrounding our operations. So we basically start a new business for the country, which is an automotive industry in Chile, just because we are in the middle of this transition, and we will see many of those opportunities happening in nearby the operations, and I assume at every part of the markets and businesses around the world. So yeah, that's more or less what I bring to you, and I'm open to discussions or questions.
Thank you, Gonzalo. I mean, it sounds like you're on a very serious track. I mean, can you hear me, Gonzalo?
Yes, I can hear you pretty well.
Yeah, I mean, really interesting set of slides, and obviously you're well down that transition. Have there been any surprises, positive or negative? The fact that you've developed these sort of cost models, have they reflected in reality what you hoped for?
Yeah, in terms of energy, it's thermodynamics, so it really holds what you put on paper when what you after test on the trial. So that's there. In terms of maintenance, that's for us, it's extremely relevant, the maintenance cost, and we have a driver and a value promise from the market and the OEMs of around reduction of 30 to 50% or so, but we haven't validated that yet. Okay. So we've been trialing equipment for no more than 2 years or 3 years at the most, and the life cycle of these equipments are 6 years. So we don't know that we are not that clear on that. We have to validate that. So I can understand it will be there, but when you're talking maintenance, we are not, because the main argument is like it has less parts that move, right? That's the thing. Yeah, but maintenance is done by people. Yeah. So you have to have the right people, of course, in the site, and we don't have it. We don't have that yet. Okay. We are completely out of people prepared for do the maintenance of this equipment. So that's definitely will be probably one of the most difficult challenges to solve in the near future when we decide to scale up these mining equipments. Another aspect as well is many of these equipment will go into a battery as a service mode, and that's a service as well, and that's for now it's expensive. So that's definitely the largest, the most sensible aspect of any evaluation is how expensive is that, and that relates to the value of the battery, but also of the service itself, which is not easy. And I understand that to do the maintenance and keep the battery with a availability of I don't know. 98%, right? So that's what we need. And that's a good thing about diesel. Diesel is diesel. It's always available. So you just have to buy it and move it next to your place. But now we are dealing with assets. So our energy is confined in an asset. So that's a challenge as well.
Okay.
Yeah.
Well, thank you very much. A really excellent set of slides, and thank you for joining us today, Gonzalo. Appreciate it. Okay, so we'll move now. We'll move from mining to Norway, to Kim Massey, part of the rental group, the Zero Emissions Manager. What a title! That's brilliant. And are you there?
I'm jealous.
Are you there, Kim, with Zero Emissions?
Mr. Zero Emission is with you. Thank you for being able to speak with you today. I'm
great.
sorry that I'm not able to be with you in Hagerbach. I hope to be with you next time. So today I will do my short presentation of our evaluation of the electric equipment in Norway, and especially the little bit bigger equipment, and also in some sceneries that you might not often see. So my name is, as said, Kim Massey. I'm the Zero Emission Manager of Rental Group. I mainly focus on the machines above 25 ton. We see it as a little bit sorted with the machines under 25 tons. We focus on the bigger ones. And we, of course, have a huge interest in the seamless use of BEVs, together with charging capacities, and making it easy to use the electric machines. Of course, and also via our interest in Subspace Energy Hub, are very interested in the fire safety and the safety of the machines, and also with the underground usage. We do also have a huge interest in the collection of machine data and the usage and the new knowledge of the machines via collection of the data. So I would like the next slide, please. Just to give you a short insight on where we are foreseeing the zero emission construction sites going in the next years. So at the moment, Rental Group, we have a total fleet acquisition of around 350 million euros. At the moment, we have acquisition cost of zero emission machines of around 35 million euros, currently about 10% of our fleet value. We are investing at around 80 to 100 million euros scheduled in new machines for 23 to 26. And we are targeting a 50% investment to be zero emission machines by 2026 and 80% by 2030. And I can already tell you by 2024 we are ahead of schedule. So this just gives you a heads up on where the market is going in the Nordics, and that we also see a huge interest in our zero emission fleets.
Fantastic.
So next slide, please. This is just to give a short insight in the two machines or two machine groups that I will focus on. And that's mainly the lead-going wheel loader, which has a relatively huge battery pack, 423 kilowatt hours. CATL batteries, capable of charging at 240 kilowatts. And then this gives you, in a 3 to 5 year perspective, up to 70% lower operating costs. So next slide, please. Also, I would like to give you some insights into two wide-body trucks that we currently run in Norway, the Sani SKT90 and the 105. They are currently at 50 and up to 70 tons of payload, 422 and 564 kilowatt-hour battery packs, both fast charging, 300 kilowatts. They are powerful, actually a little bit too powerful, because the trucks are fast and they go faster than their competitors. Machines are safe and up to all standards that we need, user-friendly, and they have huge opportunities of cost saving in the right applications. So next slide, please.
Today we are here at Filefjell. We are testing our electric wheel loader which carries the snowblower in harsh conditions. We will run the machine here for 24 hours straight and hope for operations for at least 22 hours. It's now 6:30 in the evening. Machine has been running for 6.5 hours. SOC of the battery is 58%. It's about 3 in the night. Machine has been charging for 1 hour. SOC is about 40% now. It's now 24 hours since we started the test. The machine has been operating for more than 22 hours. With 2 hours of charging for a 20-ton wheel loader in minus conditions, this is truly impressive.
So, next slide, please. I'm sorry, but did you get sound to the video?
Yeah, we did.
Okay, good. So what we did there, we run a wheel loader, 20-ton wheel loader for 24 hours. We achieved 22 hours of running time. Of course, the snowblower at the moment is a diesel version. We are looking at converting or rebuilding a new snowblower to be fully electric at the moment. But anyways, we show the capabilities of the machine and we think they are pretty good. We saw a power consumption of the wheel loader at around 680 kilowatt hours with a average consumption of around 31 kilowatts per hour. For a diesel machine, comparable, Caterpillar 950 or the Volvo 110, they have an average consumption at this kind of application at around 17.5 liters per hour. So just regarding the 24-hour test, it gives you relatively good savings just to move to the electrics. And also we are capable to show that the electrics work in harsh conditions. When we performed this test, we had around a basis of around 0 degrees down to -8 degrees. So also at those conditions, we show that electric equipments do the job they need to, compared and also in comparison with good charging facilities. Into numbers, this gives you a saving of the total cost for the power consumption is around 1,360 NOK, compared to a cost of around 6,160 NOK in diesel, which gives you around 130 euros in cost for electricity and around 600 euros in cost for diesel. So just by that short time, in 22 hours, you have relatively huge savings just in diesel compared to electricity. Electricity at this site is around 2 cents per kilowatt. The diesel price is around 1.4 euros. So there we have the numbers, and you also see that it's a relatively huge cost saving moving electric, but also, of course, you see the bigger savings in the lifespan of the machine. At the moment, I heard Liugong has one machine that has run for more than 30,000 hours with the same battery package, and now has a total or has the state of health at around 90%. And that's much higher than we have predicted.
That's pretty good.
So we can move on to the next slide, please. This gives you an example of the power consumption analysis that we do together with Sani for all our customers and the applications we move into. You see here that we are working with the battery pack for 23 kilowatt hours. We do have here a total power consumption of 2.75% per round trip, and that's hugely low. So this calculation just shows you that in the right applications, relatively flat or loaded downwards, there are huge benefits in going electric for mass moving.
Which would be the case in most tunnel projects as well, right?
Absolutely. If you do the tunnel projects in the right way, it's completely comparable to what we see here. So at the moment we have 9 Sany SKT90 wide-body trucks working in tunnels around Oslo. But they are at the moment charging outside, only working inside the tunnels, but charging outside.
Yeah.
So I can do the next slide, please. So I do talk a little bit about parameters to evaluate regarding electrification of the mine sites, and especially we do need to concentrate about topography of the mine site. We do wish to go hold flat or downwards to have the maximum recuperation of energy. It's extremely important to have good road conditions because they compare relatively direct to the consumption of the machines and also the recuperation of the machines. We do a good analysis of the mine sites up front, together also with the route calculations. Together we also look at the grid power available to see what chargers we need on site. And just to talk a little bit about the picture we see here. This is the Sany SKT 105. At this mine site, it moves around 70 tons per load. On a 3-kilometer round trip, it has a consumption of around 3.88 kilowatt. So that means that this machine has a usage of around 300 kilowatts per day. And that gives this machine, it's charging around 10 hours each night on a 30 kilowatt charger. And the cost of electricity is also around 0.2 cents or 2 cents euro. So, and compared to other machines running at that mine site, which is Caterpillar 775s, they run at an average of around 30 liters of diesel an hour. So in short terms, you have also here in the good conditions and the good right applications, huge saving for the mine sites from day one. Yeah. And the costs actually, they tend to even increase or spread even more as the runtime of the machines are longer, because then you have much more maintenance of the diesel engine and the after-burning system of the engine. So the costs of the machines, they actually stand even more further from each other when you run the machines for more than 2 to 5 years.
Okay.
So that was a little bit insight of what we're doing and where we see the electric machines and where we see the beneficial production of the electric machines and where we actually stand today.
Yeah. Thank you very much, Kim. That's really interesting. And I just wonder whether you've got a few comments about this idea of choice that clients have on machines versus legislation, and how that is in Norway, and why is Norway so far ahead particularly even in the domestic car market, but also in the construction and mining markets with BEV introduction, right? And when you look globally, it's way ahead. Is it like incentivized? I mean, is it legislation that's driving it?
Of course, we have both legislations and laws that actually regulate that we need to move into zero-emission work sites. It's a combination. The work site you see here, they want to move to electric because they have huge beneficiaries in cost. But let's say for Oslo, all constructions that will be undertaken in Oslo from 2025 needs to be and has to be zero emission.
Wow.
And compared also to the car sales in Norway for 2023, 85% of new cars sold were BEVs.
Yeah. So in 2025, zero emission construction equipment, that's a year and a half.
Yes.
And they on track?
I do feel we are on track, especially for the smaller machines. We are pretty good covered. But regarding the bigger machines, the more like 70 tons excavators, 90 tons excavators, we do have a little road ahead of us. But we are working with manufacturers, and we do see possibilities now with grid-connected excavators combined with battery, which are probably introduced to the market within this year. So we think that we are pretty good on schedule. Of course, we've been working relatively hard and are being dedicated to introduce the whole machine group. Yeah. But yes, in most cases, we do cover what's going to be needed. Absolutely.
That's fantastic. Thank you very much, Kim.
Thank you for being able to talk with you and seeing the discussions you have today. They are really interesting.
I hope you can stay with us. Yeah. Good.
I will. Thank you.
Thank you. I now have Mark. He's lucky enough to have, because he missed the first roundtable event, he's got the duty of two topics.
Yeah, and also I'm kind of conscious that maybe I hogged a bit of the time on the first run, so I'll try to be a bit more fast with the time. Again, I kind of wanted to present today actual real life examples, and again, this information it's not something that this is actual information that we are today capturing from our data monitoring machine. So you can see here, I'm happy to share the slides too. So you can see here, this is the lifetime cost of a diesel transmixer. So that's the really nice thing, is that we're actually able to do direct comparison, because both our smart drive and our diesel have the same carrying capacity. To simplify things here, I've taken away the owning cost, but of course we can add that if you guys want us to do particularly for a case that you might have. We've also, you can see here in the operating costs, we've removed or left out the electricity costs, etc. But of course the operator's salary costs, etc. So these owning costs can of course be included. So really what we looked at here is the cost of ownership of just the machine from a maintenance spare part perspective. And then you can also, if I move to the next slide here, okay, so this then would be, so we gone from diesel, the smart drive, and then we have then the summary, and you can see here how we have broken down the TCO for the diesel versus the TCO for the smart drive, and you can see here then that we have brought in, for instance, the operating costs, the service and labour costs, spare part cost, and the total. And these are sort of averages. If you have, like I mentioned earlier, depending on the application, if you have applications that requires quite a lot of tramming, quite a lot of moving around, the benefits are usually bigger. And also that's because, of course, in the diesel equivalent, you have to do a lot more maintenance as well. So one kind of levels the other one out with regards. So what we would say is that machines that are not moving around so much and are fairly stationary, the advantages is lower. But with regards to machines that are moving around quite heavily, we see that in some applications the operating cost savings are quite big. So you can see here for a typical transmixer, we can see here, for instance, the total diesel saved, the CO2 saved, the total energy used, total energy charged, the total operating hours, this is just an average, but also we can see the generated energy. And I didn't try to make this slide look prettier, because this is actually a customer's machine, and this is the information that comes directly to him from our data monitoring system. So I wanted to use a real life example. Then if we take a look at a Charmec,
Which is
an explosive charging machine.
Yeah.
And we've got a lot of really good head-to-head examples, particularly in Australia, with this machine. So if you think about the scenario that you're doing a development tunnel, sort of like what you would do in a tunneling project, or you're doing a development in a mining environment where you're trying to get down to the ore body. In these scenarios, generally the magazine or the place where the explosives are on the surface, and you need to go up, fill, come back down, charge, and go back and forth. And in those applications, we've seen huge advantage of using smart drive machines. Main one being that they actually operate quicker on the ramp.
Okay, faster.
Much faster. So your equivalent diesel would be maybe 6 kilometers an hour uphill on the ramp. The battery version can do 12 kilometers. And so with those kind of opportunities, you can look at it in two ways. You can look at it that you have the potential to charge more phases. In most cases, that's not possible. But then you can think to yourself, okay, maybe today my fleet is 3 machines. Now all I need is 2. So there's those kind of operational opportunities. But then if we look at it from, and you can see here again, we have the diesel version, we have the smart drive version, and I'll skip straight to the advantages. You can see here again, compared to the logistic machines, the benefits are lower, but we're just talking about direct maintenance, labor, operational costs.
And what sort of period of time, Mark, is that? It's 344,000.
So this would be over the, let's say, lifetime, typical lifetime of a Charmec.
Okay.
And again, then we can take a look at typical types of savings with regards to diesel, CO2, and I just pulled up a random machine from I think this one is based in Australia. We can see here that the machine has been running almost 4,000 hours, and already it's saved over 10,000 liters of fuel. And you can see how much regeneration you have there as well. So the thing here is that now, after during this journey, capturing this data, we're able to get much more accurate cost per hour elements. And the good news here is that even if you don't think about the indirect savings like ventilation, moving fuel around, having all that sort of logistics, and we just focus on looking after and maintaining and the cost of ownership, there is no application that we found yet where there's not an advantage running.
There's an advantage every time.
Yeah, there's an advantage every time. So that's basically the message here, and we're happy to get involved with customers, talk about their applications, and then providing them with total cost of ownership calculations.
And the calculations that you've modelled in Normet in this case,
Yeah.
are they reflected by the real case?
Yeah, they are, and
you get inputs on energy costs.
Yes, so we're able to. We need the help. We need the help of the customer to be able to figure out things like energy costs and labour costs and that type of thing. But those that you can see here in the input parts, we've like for instance operator salary costs, insurance, tax costs, that kind of thing. We have a lot of elements that we can add here.
And I think all the CO2, does that include like source of energy?
Yes.
Whether it's nuclear or gas or
exactly.
or renewable. Or...
Yeah, so all that stuff can be taken into account. So yeah, I won't take up any more time. I want to leave the floor for someone else. But by all means, guys, if you want to get more information about this, or would be very keen to do some kind of a study around it, just let me know.
Yeah, we will.
Thank you very much.
Thank you very much, Mark. We've had some presentations from Mottix in the last roundtable as well. Quite a new entry into this sort of dynamic world of BEVs and battery management systems and design of systems for BEVs. So, Remo, please.
Yeah. Thanks for having us, for having me. First of all, Mottix. Okay, Mottix is in the business of retrofitting. So we're actually building drive units for vehicles that are in the field, because there is a large number of vehicles in the field, and at least in the next couple of years, we see that as a big opportunity. And so we've already electrified a few vehicles from Normed also, but this Toyota as well. And of course, I was asked to give our thoughts about TCOs, or total cost of ownership, like all the aspects of economics. So what you typically see, or if you talk about TCOs, is that sort of figure, where you have two lines crossing somewhere. Is it? Yeah. So.
So noisy.
That should be replaced.
So noisy.
So you have initial investments at the beginning, which are typically higher right now because of the batteries, because of the new technology that costs more now, and you also have operating costs, right? And we sort of use that graph, or that thing as an initial thing to sort of make a educated guesstimation. Educated guesstimation for where you are with that particular vehicle, right? Yeah. So you can actually boil all the costs down per kilometer. So that would be the maintenance cost, that would be the operating cost, that would be that means the energy you put into it, like diesel and or in comparison to electricity. But also, as you mentioned, like insurance costs, whatever, and you boil it down to a kilometer price, and that usually depends, and that gets you the slope where you are. And at the end, you will have a place where these two lines cross, right? And as you already mentioned, like with applications where like sprayers, where they stand a lot and don't get to drive around a lot, we see that this actually shifts a bit.
Yeah.
And vehicles that drive a lot, that usually get better, or that you reach the point quite early. So yeah, this is it, and it's actually quite an easy calculation which you can do there, and like having the initial cost divided by the delta. Actually, if you compare the delta, you take the delta of the initial cost and you take the delta of your calculated cost, divided, that gives you a sort of an estimation how many kilometers you have to drive in order to reach that point. Yeah, well, and then and also like taking a look at the scope of your consideration. I mean, most of the time what we do, what we just did, is like comparing the diesel engine directly to the battery electric vehicle. So that's sort of that first little bubble. But we've heard it a lot of times today. The benefits actually come if you widen that scope of consideration, and especially if you take a look at the whole mine, then you actually get these benefits out of it. As we heard with the ventilation, that's a big thing which the mine actually benefits a lot. And so, but like in making that bigger, you have a lot more stakeholders that have to be sort of taken into account and have to get their own benefits. So the stakeholder management becomes a necessity then. And one other thing is end of life. We heard that a lot. Like end of life. What's end of life of a battery? End of life of a vehicle is pretty clear, right? A few years, 5, 10 years max. But most of the times we actually see that the batteries, they live much longer. So, so you have sort of a residual value at the end of your vehicle life, and that battery actually still has value. So we think we have to adopt this kind of thinking into it, and sort of think about. Okay, that one is not the one I was expecting. But if we have batteries that can be used before they're actually going into use as a battery that is stabilizing the grid and is on site in order to replace the battery in the vehicle, so that's the first use case. But then it can be used in the vehicles, and at the end of the life it can be used as a stationary battery again. So we sort of, I think we can improve these economics even further if we take into account these kind of concepts.
Full life, yeah.
These circular economy thinking. And our sister company Model is actually doing this. So you've mentioned that before, I think in the introduction.
Yeah.
They're actually doing that. They're taking the old batteries and giving it a second life. And I think, or we think, that this is really a good thing to do within the mining as well, within tunneling as well. So, yeah.
Yeah, thank you very much, Raymond.
All right.
Yeah. I mean, thanks for your time.